Hey, good morning. First day of remote learning. We got our calculators ready. We're sitting by the periodic table. It's time to go. Hey, we're going to go into our solutions folder, and this is going to be the same for chem and STEM right now. But go into your solutions folder, and you're going to open up number 5. It's called Dilutions Equation Worksheet. We are not going to do the same amount. STEM is going to stop after the first page. Chemistry is going to do both pages. Not that much work. We should be done in a little bit. We're going to get it moving, though. So let's get started. Open this thing up here. Let's go in here and just resubmitted in new papers. So hopefully it works out. If something's not showing up, let me know. Give me a ring-a-ding on the old remind, and we'll see what happens. This is a dilution. A dilution means we're going to water things down. We're not going to water down the lesson. We're going to water down is the solution. Now remember, when we add water to something, we're not changing the number of moles. We're not changing the stuff that's inside there. What we're changing is the amount of water. So this equation is the quick way to figure out what the molarity is, the concentration, the big M, right? And here's our equation. Can we see that? I'm going to blow it up a little bit. There we go. I got my calculator here. If that goes off, it's going to make me mad, so I got to keep tapping it every once in a while. Okay, so this up here is our molarity equation. M1 times V1 equals M2 times V2. So that's the equation. That big M stands for the concentration of the molarity. The V stands for the volume. Now, today, volume can be either in milliliters or liters. It doesn't matter. It's going to be a ratio thing, so we're good to go there. So either label works. Just be consistent with your labels. If there's 1 milliliter, they're both milliliters. If there's 1 liter, they're both liters. They have to be the same. Let's get started. Okay, so here's that equation. So this is condition 1. This is what happened before we added extra water. This is condition 2. This is after we added the extra water, or vice versa. Condition 1 or condition 2, it doesn't matter which one you put it on, the equations will work out the same either way. What I like to do, and I just did it, I'll show you what I did, is I clicked the text button here, and then I highlighted that equation. Now I'm going to change my font so you can see a little bit. I'm going to go up to 18. And I'm just going to copy and paste that. So I pushed Control C, and then I'm going to push Control V. Oops, I didn't push Control C. Go up there and highlight your equation. Push Control C, go down to your problem, push Control V. And there's your equation. It just moves it where you want it, and we're going to use that every time. If you want to paste that in on every one right now, pause the video and do that. All right, I'm not going to do that. I'm just going to keep flipping back and forth. I did put answers here on the sides, so there should be answers for each problem if you're ready to go on without me. Remember, STEM's doing page 1, Chem's doing page 1 and 2. All right, here we go. So a stock solution has a 1 molar NaCl. A stock solution of 1 molar NaCl is available. How many milliliters are needed to make a 100 milliliter of 0.75 molar? All right, so what we have to do is find our ones that are pairs. Look at this right here. I see it right here. 100 milliliters of 0.75. That's a pair. They're together. So we can put that on one side of the equation. It doesn't really matter what side of the equation. I'm going to put it on M1 just because it's right there. So I'm just going to go into my thing, and I'm just going to, let me move this over a little bit, and I'm just going to, come on, Ed. I'm just going to copy it, label and all, copy, and that's my V1, and I'm going to pop that in here. I'm going to put parentheses down so I don't have to write any times or anything, and I'm just going to paste it right in there. Oops, what happened? All right, I got some weird stuff going on here today. There it is. Okay, and so I just put that in parentheses. Now, the M1 was the thing with it, the 0.05, so I'm just going to copy that number also. Copy, and I'm going to paste that in. Looky there. One side of the equation is finished. the stock solution was 1 molar. So 1 molar, I'm going to copy that. I'm having a bad copy day. It's early. Copy, and I'm going to put that M right here. Okay, now parentheses if you want to make it look cooler. And there we go. And we're solving for V2. All right, and the answer I solved for V1, but that's okay. It doesn't matter, remember. Now remember when we're solving these equations, we're doing our quick algebra. Oops, our calculator is gone. So we're doing our quick algebra, and our quick algebra just means that we are not going to rewrite it. We're just going to do the math in our heads. Okay, there she's back. All right, so in my calculator, let me move this over to the side and shrink it down a little bit. Oh my gosh, it's ridiculously large there. All right, so we go over here, and look what we have. 0.75 m in 100, right? We're solving for V2, so always go to the opposite side of where the variable is. So take and put those numbers in. So we're going to put in 0.750, and we're going to times that by 100, just like shown on the paper, right? Now you have a 1 over here. We want to get that away, so we're going to move it down and below, so that means divide. So we're going to divide by 1. I know we don't have to really divide by 1, but we're just trying to show you what happens there. And what do we get as an answer? We get the answer of V2. I just put the answer, 75 milliliters. All right, easy peasy. All right, let's copy that equation again. So again, if you got it, go ahead. You don't have to wait on me. You know, I chit-chat too much. There we go, equation's in. What is the volume, so we're looking for V again, of 0.25 mkcl? It's needed to make 100 milliliters of 0.1 molar solution. So here's our pair over here, the 100 and the 0.1. Let's put them in. So this is a V, 100 milliliters. Now if you can type faster than you can copy paste, that more power to you. I'm going to put that one on this side this time. It doesn't matter, remember, as long as I keep my pair together. That's what's important. All right, and I'm going to put that pair together by getting my molarity, and I'm going to put that right here for M2. All right. Second thing, what volume of blah, blah, blah? Here we go, 0.25 m. So we're going to take that, and we're going to put that, copy, paste, parenthesis. Oops, that's not a parenthesis, parenthesis. All right, and that's nice and pretty now. All right, and we're trying to solve for V1. Calculator. Hey, it stayed on for me. So calculator, we're going to go to the other side of the equation first, over here. So 0.1 times 100, 0.1 times 100, right? And then divide by 0.250 equals, the answer is 40 milliliters. We're right on task. See that? And it's going pretty quick. STEM kids are almost halfway done. Moving it up, moving it up, moving it up. Okay, so here we have, this is a lot like I did in the lab the other day when I made up that acid for you guys. Now this is sulfuric acid. I made hydrochloric acid, but the same idea. We have an 18 molar concentrated sulfuric acid. That's really strong. And we needed to have 2 liters of 1 molar. In class, I made 1 liter of 1 molar, right? Same idea. So let's get that equation first, because I just like to pop that right in that equation spot. Let's copy. Keeps everything. I don't have to retype an equal sign then. All right. So I'm going to paste that in, and I'm just going to go 2 liters. Copy. Put that in for my volume. I'll call that V2. I'm just mixing it up because I can, right? Put that in there like that, and then I'm going to find my molarity, which is 1m, so copy, paste that in for my 1m for that. There we go. All right. The concentrated was 18m, so let's put in 18m here. Oops, I just typed it. If you can type it faster than you can copy paste it, do that. That's whatever's fastest is the best, right? There we go. Now, we're solving for this thing. And so we have to go to the other side of our unknown, which is V1. So 1 times 2 first. 1 times 2, we know that's 2. And then divide by 18. Divide by 18. And there we go. 0.11 milliliters. Right? I don't care where you round, as long as you round at something that doesn't distort the answer too much that we don't know what it is. All right. So STEM, there's 3 of them. So 2 more. Can you do 2 more here? Right? We're going to do the same exact thing. I'll get you started on this one. Copy that equation. Copy. Paste it in. Right? Look what we have here. We have a pair. I can see it right there, 2 liters and 1 m. We have something by itself, right? So it's pretty easy to do. Concentrated HCl is 12 molar. Put the 12 molar in, right? And then we needed to make, here's the other pair, so put 12 molar on one side with a V, and put the other 2 on the other side and multiply, right? And then multiply them together and divide by 12. All right? Do that same thing for number 5 here. See that? We got it going on here. So we have a 0.5 molar solution. It's being diluted to 500 milliliters of, all right. So we have a 0.5 molar solution is being diluted to 500 milliliters of a 0.150 molar solution. So this is our pair. Put these on one side of the equation, these 2. Put this on the other side of the equation and solve for the missing V. All right, STEMs, there's 2 that you got to do. Good luck. Chems, we'll keep going. We're going to keep moving. I'm going to do another one here, and then I'm going to do a hard one at the bottom. Okay, number 6. Again, let's see if I can keep that equation in here. Again, if you know what you're doing, don't wait on me. Just go. They're not any different, though. A stock solution of 10 molar NaOH is prepared from this solution. You need to make 250 milliliters of 0.375 molar solution. How many milliliters will be required? Same old, right? Copy your pair. Copy. Decide what side you want to put it on. I'm going to put mine on the 1s this time, just to mix it up, to make it fun. All right, and I'm going to get this molar right here. I'm going to copy this, and I'm going to put that for M1. I'm trying to go fast so you guys don't get tired of listening to me. And then I have 10M, and I'm going to put that 10M, and I'll put that on this other side. Copy, paste it in, maybe some parentheses around it for fun. Boop, and boop, there, oops, that's a 9. There we go. Oops, and my calculator just about went dead. There, we're back. Good. All right, so multiply the 2 on this side first. 0.7 or 0.375 times 250 divided by 10 equals, and there's our answer, 9.35. Okay, try number 7. It shouldn't be bad. Number 8. Nothing different about number 8, right? Everything's the same so far, so you shouldn't have any problem. Just copy and paste that problem in there. Now, one thing on 9 I do want to talk about is I accidentally put the answer in milliliters. So there's a liter answer there for you too, all right? I converted it. I don't know why. I just did, but I have it in liters also. Number 10, same thing, nothing different on number 10. For some reason, well, they solved for molarity this time, but then they wrote moles over liters. That's just molarity, so just a capital M is your answer. Should be pretty straightforward. You're just solving for M this time. All right, let's do the big daddy here at the end. There's always one fun one at the end, and this is this last problem. So number 11 is a 2-parter. And this 2-parter says we have 100 grams of sodium hydroxide. I put the mass there. It's 40 grams. You look up at the table, 23 plus 16. Can't see it, but it's up there. Plus 16 plus 1 is 40. So that's the mass of sodium hydroxide. and it's dissolved in 1.55 liters. All right, so that's molarity. Molarity, we have to use our molarity equation. And so I'm going to do trawling style, I think. So big M equals, and you could type it. Remember, we typed it. This is from the other paper that we did the other day. We have moles over liters. That's our equation. We just have to match our labels up with that equation. Look right there, 1.55 liters. That's easy. It's already done for us. 1.55. Right? Moles. Here's where, look at that. They gave us 100 grams. We need moles. We have to make the grams fit that equation. So we're going to change grams to moles. Easy peasy. So 100 grams, I'm still typing or still writing with my finger for some reason, but we'll do it, right? 100 grams to 1 mole. And what do you divide it by? From the mass from the table. Remember, moles is always 1, and the mass always comes from the table. That's 40 grams. All right, my goal again is always to get these problems set up before the calculator goes out, and it worked, so we're in. So we take 100 divided by 40, and that equals 2.5. We could have done that one in our head, huh? So 2.5 moles. All right. Well, that 2.5 moles goes right on this equation. I'm going to put it above because I don't have room below. All right. And so my molarity is 2.5, which I have in the calculator already, divided by 1.55 equals. The concentration of that solution is 1.6 capital M. All right? That's the first step. That's A. One part done. Okay, B. If the solution is diluted to a volume of 2.75 liters, determine the molarity. You know what they did? They just poured some water in it, right? So they poured some water. And let's see if this equation is still in my calculator. It's not. So our equation is M1V1 equals, our equation is M1V1. Ooh, mine's ugly this time. Equals capital M2 V2. That should have been capital. I'm going to at least put a capital for that M because, you know, the kids will make fun of me if I don't. All right, there we go. So there's our equation. So we just have to sub the things in the right spots. All right, let's see what we have. All right, molarity. We just calculated molarity. So the molarity is 1.6 M, 1.6 capital M, right? The volume, right? Look at the equation. The volume is in the equation. It's 1.55 liters. All right. And then we diluted down. We added water. How much water did they add? They filled it up. See how they wrote that. The solution is diluted to a volume of 2.75 liters. And they wrote it that way so we know exactly how much, we know exactly how much liquid is in that solution at the end because we need that with molarity. And then we have our equation. We have one. Now I'm not going to round. This is already in my calculator. So I'm going to take that 1.6 times 1.55 and then divide it by 2.75. Boom. There's my answer. Hey, it matches the answer on the paper and looks like we're in business. All right. That's it. That's dilutions. They're not hard at all. And I hope you have a pretty good first day. I know that took a little bit of time, but hopefully not so long that it ruined your whole entire day. Hey, have a great day. I'll be back tomorrow with something quick again. Again, if you know how to do it, keep rolling. If you have missing assignments, make up your missing assignments. All right, have a wonderful day, and I will be back tomorrow.